So how can we colonize Mars quickly? Mars is impossible. We all know that all hell breaks loose as soon as we set foot on Mars. From low gravity to harmful radiations. We'll need to face challenges we've never faced before and prepare for the unexpected and also for the unimagined. While it can be fun to imagine living life on a new planet, the reality is that we would need constant supplies and support from Earth, access to food, water and oxygen, a way to travel within the planet, and also an emergency exit plan to leave Mars if something goes terribly wrong. But just for the case of speculation, how could we do all this quickly? Maybe one of the ways to colonize Mars would be to nuke its poles, as sarcastically suggested by Elon Musk. You see, the basic idea is that if we nuke all the poles, all the ice would melt and sublime. You see, the ice sheets of Mars are not just made up of water, they consist of carbon dioxide as well. So by nuking the poles, we would get liquid water and also more carbon dioxide, which is a greenhouse gas, and it can be used to help to heat up Mars. But let me tell you why nuking the poles is a terrible idea and how there are better ways to do it. But first, let us look at humanity's craze with nuking stuff. First of all, we need to be very precise and detonate nuclear weapons such that they cover the entire Martian ice cover. Secondly, if we did that, we would sort of Chernobylize the whole planet with radioactive elements. A radioactive cloud would quickly disperse all around Mars, making it hazardous for anyone who went there. It also has chances of resulting in a condition called a nuclear winter. But the worst part is that over time, the radiation would seep into the Martian topsoil, which is a critical resource for its use as a building material. It also contains water, which future colonies could extract. So by nuking Mars, we would only make it even more inhospitable. And even if we wanted to, it would require thousands of nuclear warheads to strike the intended radius. So to strike the ice, we would need thousands of nuclear warheads or one large enough asteroid. If we could just get hold of a large enough asteroid hovering nearby and shoot it at the ice, we could get the same intended effects without all the radioactive stuff. But do you know what would be better? 2 asteroids, each aimed at the 2 poles, and our job could be made a lot more easier. NASA is already working on a mission to send a probe to an asteroid to collect samples from it. Maybe this technology could be used as a prerequisite for redirecting asteroids. Another possible solution proposed is to use huge orbiting space mirrors around Mars to concentrate sunlight into really concentrated and powerful beams and point them directly at the poles. This would make them to sublime and melt the ice in a much shorter time period. You see, water and temperature are only 2 of the frustrating problems on Mars. Earth after nuclear war would be a more livable place than Mars. To build a colony much faster on Mars, we would have to use the resources available on Mars itself, since the closest travel window between Earth and Mars is once in every 2 years, so we cannot depend on Earth. That set aside, we would have some fundamental requirements. First, we need to choose a location for our base. It would be better to set one up near a water source. Setting up a base somewhere near the poles is what any sane person would do to ensure access to water. The poles also harbor other natural resources like carbon dioxide, iron, aluminium, silicon, and sulfur, which could be used to make things like glass, bricks, and plastic. And with a little work, they could even use the planet's hydrogen and methanol to create fuel. But we would be using solar panels along with nuclear fuel to initially supply energy to our base. But these resources will not be readily available, so we would need to send a bunch of robots first to start building the foundations. But poles are elevated surfaces on Mars. This means that they have higher exposure to harmful radiation, which can increase the chances of cancer. Our shelters must be protected from these radiations. Some experts have even proposed moving shelters. New and recent studies show that there are other locations on Mars that are not much elevated but have water below their surface. These locations can also be used as bases. We would also have to combat the problem of low gravity. Even after consistent exercise, astronauts from the International Space Station had walking problems when they returned to Earth. In addition to regular physical exercise, we would also have to find a way to kind of simulate gravity inside shelters to tackle the problem. Settlers would have to spend most of their time indoors and use protective suits while going outside. If we really want to speed up colonizing Mars or any other planet, we would have to develop one technology here first on Earth, and that is automated mining processes. Mining for materials should be possible to do with autonomous robots efficiently and without too much human intervention, because that same technology can be used on Mars to extract minerals and even deep water under the surface. But what about oxygen? Just to be clear, we need oxygen to breathe, and also to potentially make rocket fuel to go back to Earth. The generally proposed idea goes something like this. The Martian atmosphere has too much carbon dioxide. We can potentially extract oxygen from all that carbon dioxide. The technology is really being tested on NASA's Perseverance rover. But there is another interesting and very promising way to get oxygen, and that is by using cyanobacteria. These are photosynthetic microbes that can thrive in CO2-rich environments and can give out oxygen. A recent breakthrough happened where biologists inserted an extra enzyme into a certain strain of cyanobacteria. It allowed the organisms to emit ethylene gas while metabolizing sunlight, water, and carbon dioxide. Ethylene is the basic building block of plastics and can be polymerized to build all sorts of materials. Entire cyanobacteria farms can be built to supply a stream of ethylene for a range of building materials. During that photosynthetic process, they can also release oxygen, which colonists could capture and store. But there are two words that can completely change about how we think about colonizing Mars, and those two words are genetic engineering. With significant breakthroughs in genetic engineering in the future, we can possibly make humans better adapted to Mars's gravity and radiations, make more plants grow in Martian soil, and make cyanobacteria thrive in cold temperatures of Mars and give out more oxygen. It just needs more funding, research, and time. We have all the required materials in some form or the other to sustain life on Mars, but what we don't have is food. Mars is devoid of life and there is no food. That is one thing that we need to bring from Earth. Martian soil has toxic perchlorates, lacks nitrogen, and cannot be directly used to grow plants. Even if we remove those toxic substances, only certain plants like spinach, onion, and garlic could be possible. But life on Mars is going to be lonely, so the first crew members would definitely need more variety in their plate than just plant-based diet. We certainly cannot bring livestock like hens, cows, or pigs, since they would require a lot of resources like water, energy, and maintenance. It is also not practical to physically transport them to Mars. So scientists are looking into, well, insects. Yeah, you heard me right. Many people believe that insects will be a normal part of the Martian diet if people get over the gross factor. Some insects like crickets and bugs seem to have a fair amount of nutritional value. To give even more variety, settlers could eat lab-grown food, as everything from algae to meat and fish to cowless milk and chickenless eggs are now possible. But the funny thing is that with all these challenges in place, Elon believes that we'll have 1 million people on Mars by 2050. I don't know about that, but it feels a little bit too optimistic. A colony of 50 people with continuous shifts seems more like an achievable target. But an even more interesting question is whether the general public would want to live on Mars with all these risks and restrictions. And should we colonize Mars in the first place, or focus more on saving Earth? Well, that's a controversial topic and demands a separate video. But until that, comment down what you think will be the fastest way to colonize Mars. And if you enjoyed the video, please do consider subscribing to the channel and turning on the notifications. Oh hey, still watching the video? I almost forgot one of the most important ways to colonize Mars. If you want to do it quickly, just tell the United States that Mars has oil, and we'll have a self-sufficient colony on Mars by a couple of years. It's that simple. Just note that idea down, and I'll see you next time.